In today's video, we're overclocking the Intel UHD Graphics 770 integrated in the Alder Lake Core i9-12900K CPU all the way up to 2378 MHz in 5 minutes or less using the Asus Maximus Z690 Extreme motherboard and EK Quantum custom loop water cooling. I'll speedrun you through the BIOS settings and provide some notes and tips along the way. Please note that this is for entertainment purposes only and definitely not the whole picture. Please don't just copy the settings that you see in this video and apply them to your system. If you want to learn how to overclock this kind of a system, please check out the longer Scatterbencher video. Alright, let's do this. When you've entered the BIOS, go to the Extreme Tweaker menu. Set AI Overclock Tuner to XMP2. This will load the full XMP profile and let our DDR5 memory run at its high performance specification. Set BCLK frequency to 116 MHz. The base clock frequency is the reference clock for a lot of parts inside your CPU. In most overclocking scenarios, you never have to increase the base clock frequency as there are plenty of multiplier ratios available to push your cores or memory to the max. However, the Alder Lake integrated GPU overclocks so incredibly high that the available ratios up to 42x are simply not enough. Increasing the base clock frequency impacts a lot of parts inside the CPU, so we'll need to adjust other settings accordingly to ensure stability. Set Asus Multi-Core Enhancement to Enabled Remove All Limits. This will unleash the Turbo Boost 2.0 power limits and allow for an unlimited time at maximum performance. Set DRAM frequency to DDR5 6264. This ensures that the DDR5 memory is running at a stable near XMP frequency despite increasing the reference base clock frequency. Set performance core ratio to by core usage. Now we will configure the CPU P-core turbo ratios such that the turbo boost behavior mimics that of a standard Core i9-12900K. As we have adjusted the base clock frequency, we must reduce the CPU core ratios. We set the ratios for each of the active P-core configurations accordingly. Set 1 core ratio limit to 45. Set 2 core ratio limit to 44. Set 3 core and 4 core ratio limit to 42. Set 5 core, 6 core, 7 core and 8 core ratio limit to 41. Set efficient core ratio to by core usage. Just like how we adjusted the P-core turbo ratio configuration to mimic the standard behavior of the 12900K, we will do the same for the E-cores. Set efficient 1 core, 2 core, 3 core, and 4 core ratio limit to 33. Set efficient 5 core, 6 core, 7 core, and 8 core ratio limit to 32. Set max CPU cache ratio to 32. Set max CPU graphics ratio to 41. This increases the graphics frequency. There are two important things to know about the graphics ratio. First, the graphics frequency is derived from the base clock frequency, but first halved, then multiplied by the graphics ratio. So, in our case, the base clock frequency of 116 MHz is first halved to 58 MHz, then multiplied by 41, resulting in a frequency of 2378 MHz. Second, on Alder Lake, the slice and unslice are decoupled, meaning they run at different frequencies. When adjusting the graphics ratio, we only change the slice frequency and not the unslice frequency. That said, the unslice frequency is still affected by adjusting the BCLK. Set BCLK aware adaptive voltage to enabled. This is a crucial setting, ensuring the factory fused voltage frequency curve is used correctly when overclocking the base clock frequency. The long story short is that the factory fused voltage frequency curve maps a voltage against a ratio. When the CPU boosts to a high frequency, it references the voltage frequency curve using the configured ratio to know which voltage to apply. In our case, we have increased the BCLK frequency and decreased the CPU ratios. With 116 MHz BCLK, we set 45x to achieve 5.2 GHz. Without enabling BCLK aware adaptive voltage, the CPU would look up the voltage for the 45x ratio, then use this for 5.2 GHz. This would obviously not work out very well. By enabling this setting, we tell the CPU to account for the adjusted base clock frequency, and the CPU will use the appropriate voltage based on the effective frequency as opposed to the configured ratio. Set CPU graphics voltage to offset mode. This allows us to increase the graphics voltage to support the overclocked frequency. Offset mode allows us to offset the entire factory fused voltage frequency curve for the graphics by a certain amount. Set CPU graphics voltage offset to 0.35. This will increase the minimum voltage of 0.9 volt for 300 MHz to 1.25 volt for 348 MHz, and the maximum voltage of about 1.05 volt for 1550 MHz to about 1.37 volt for 2378 MHz. Then save and exit the BIOS. To make sure everything is working as intended, we rerun some benchmarks and check the performance increase compared to the default settings. With the integrated graphics now running 53% higher slice and 16% higher unsliced clock frequency, we see the highest performance in all benchmarks. When running the Furmark GPU stress tests, the average GPU slice clock is 2378 MHz and the GPU unsliced clock is 1566 MHz with 1.375 volts. The average memory clock is 3132 MHz. The average GPU temperature is 60 degrees Celsius. The average GPU power is 31.70 watts. And the average water temperature is 28.9 degrees Celsius. And that's it. Thanks for watching and see you next time.